Hello, today we're going to show a demo of using VMware Big Data Extension to automate deployments of PivotalHD in a VMware environment utilizing native HDFS integration with EMC Isilon storage. VMware Big Data Extension is a free download from VMware that integrates with your existing vSphere environment to automate deployments of Hadoop. Once the extension is deployed in your environment, you access its resources through the vSphere web client. As you can see on the left pane, once installed, we have access to the tab that brings us into the management features of the Big Data Extension. Big Data Extension supports multiple Hadoop distributions including Cloudera, MapR, Hortonworks, Apache, and PivotalHD. For this demo, we'll be looking at how to deploy PivotalHD with Big Data Extension. Big Data Extension utilizes Chef to automate the deployments of the Hadoop distributions. Out of the box, Apache is set up to deploy immediately. The other distributions take some setup. PivotalHD requires us to set up a Yum repository for Chef to access for automating the deployments. In this demo, we've created the Yum repository locally. We've downloaded the RPMs and put them within the Apache directory under PHD1 and created a repo. As we look through this directory, we can see all the information is here that a Yum install will require to deploy Pivotal on a node. Specifically, we'll look at the phd.repo file that contains the published web page to retrieve the RPMs. If we open up a URL that points to that phd.repo file, we'll see the same information that we saw through the cat and the CLI. So now let's go do a deployment. So we switch back to the web client and we click on the Big Data Clusters tab. Underneath there we'll see any clusters that we've already deployed, and we have the option to deploy a new cluster. We click the Deploy Cluster button and we get a wizard that pops up that asks us for the variables of the cluster deployment. These variables are utilized by Chef during the deployment of Hadoop. So we pick the Pivotal distribution and we pick the deployment type. The deployment type allows us to select the type of deployment we want Big Data Extension to do. For this demo, we picked the compute-only deployment type. This allows us to use an external resource for HDFS. In this example, we'll be using EMC Isilon HDFS. We then set the variables for the worker, data, and client nodes. These variables are basically the size of the VM that we'll be deploying and its location, whether it's on local or shared storage. Once we've entered that information, we also choose a network to deploy it on and a resource pool within vSphere that the deployment will take place in. After we've entered all that information, we submit the job, and Big Data Extension begins the automated process of deploying the Hadoop cluster within vSphere. As we mentioned earlier, Big Data Extension utilizes Chef to automate the deployments of Hadoop in a virtual environment. Let's take a look at two of the relevant files. The first file we'll take a look at is the manifest file. The manifest file contains information about the distribution. This information includes the vendor, the name, the version number, and where the packages are located. In our example, for Pivotal, these packages are located in the repo that we showed earlier within the demo. It also contains the role information that is used for Hadoop during deployment. These roles include name node, resource manager, client, server, master, etc. All the distributions we've set up for Big Data Extension will be shown in this file. The next file we'll take a look at is the map file. The map file contains information for each distribution about the deployment type. The only reason you would ever have to edit this file is if you're using a different version for a Hadoop distribution than one that is previously configured. So we do a cat on the map file and we'll see entries for all of the different distributions that Big Data Extension supports. For Pivotal, we'll see 4 entries that map out to the deployment types that are supported with Big Data Extension. We're specifically looking at the compute-only deployment type because that's what we're doing, and this information here shows us where the JSON file for that information is kept. Finally, we'll take a look at a log file. This log file is called IronFan and is kept within the log directory. This file contains all the information about the deployment. So if you have any need to troubleshoot or look at how your deployment is going, you can either cat or tail this file to see that information. As you can see here, we're running a live tail on it, and we can see the different nodes that are being used for our distribution and their status. Our deployment is now complete. Let's dig into it and look at what happened. So here we can see the two nodes that have been deployed as part of the Pivotal distribution. We'll switch back to the CLI so that we can look at the log files to get information about our deployment. Again, we'll look at the Iron Fan log because this contains all of the relevant information about a deployment, success, failure, and it's absolutely your best place to start troubleshooting if you have any deployment problems. As we look at this file, we'll see the same information we saw through the web GUI about the different nodes for our Pivotal deployment. So we see their names, that they're service ready, and their IP address. Next, we'll use the vSphere client to look at the cluster. As you can see, we created a resource pool that contains all of the nodes of our cluster. We'll open up a console to the master so that we can verify the status of the cluster. During deployment, nodes are given a randomly generated password. And as you can see at the top of the screen is the information to change that password. It's a script called Sarengeti-password. So once we log on, the first thing we'll want to verify is that Java is working and that we have access to our HDFS Isilon. We verify this information by running a Hadoop file system list command, which will verify that Java is indeed working and that we have access to the HDFS directories on Isilon. Next, we'll run a yum install command to verify that we use the correct repo. We run yum install Hadoop, and we'll see that it's already installed and that we're using the Pivotal Hadoop distribution. We'll change our directory into the yum repo.d under etc, and then we'll see the same PhD repo file that we saw at the beginning of this demo. A count of this file will show the exact same information that we saw earlier. For more information about EMC and Pivotal, please go to bigdatablog.emc.com.